Okay, welcome to homework number 3 with circles. We're going to talk about arcs and chords today. The information you need is right here, so you can always pause and write this down as soon as I've explained everything. Two chords are congruent if and only if. Remember, we talked about that when we did proofs, that it goes both ways. If P equals Q, if P then Q, and if Q then P. So two chords are congruent if and only if their corresponding arcs are congruent. So for example, if the length of AB is equal to the length of CD, then their intercepted arcs will be congruent. So the measure of arc AB will be equal to the measure of arc CD. The reverse is also true. If the measure of arc AB is equal to the measure of arc CD, then those arcs will be congruent as well. Second thing with chords, if two chords are congruent, if and only if they are equidistant from the center. So if AB is the same length as CD, then they are the same length from the center. So the length of EF has to be equal to the length of EG, and the converse is the same as well. The next point is if a diameter or a radius is perpendicular to a chord, then it is going to bisect the chord and it bisects the arc. Using those facts, we're going to do 3 examples. So example 1, if we look at this picture, we see these two chords are congruent. If two chords are congruent, then their corresponding arcs are also congruent. So if these chords are congruent, then these arcs are congruent. So we can say that 11x minus 72 will equal 5x plus 6. And then we just solve. So we subtract 5x from both sides, and we add 72 to both sides. Divide both sides by 6, and x will equal 13. Make sure you answer the question though. The question says find the measure of arc RS. So we need to find the measure of that arc. Well, we know that the measure of arc RS is this equal to 11x minus 72. We know our x is 13, so when we plug a 13 into there, we will get 71 degrees. When you are doing the Canvas quiz, which is truly just a daily grade, do not put the degree sign. Okay, moving on to example 2. Example 2 says if the measure of arc CI, so this part right here, is 7x minus 15, the measure of arc EF, this whole thing, is 12x minus 8. We want to find the measure of arc CI. Well, if we look at this, we know that these two segments right here are congruent. What that means is that these arcs are equidistant from the center. And looking here, if arcs are equidistant from the center, then the chords are congruent and the corresponding arcs will also be congruent. So therefore, the measure of arc EF is the same as the measure of arc CD. Well, we don't have this whole thing, but we also know that if the radii are perpendicular to the chords, that it bisects the chords and it bisects the arc. So if this is 7x minus 15, this side also has to be 7x minus 15. So this entire arc is congruent to this entire arc. So we can do 2 times 7x minus 15 is equal to 12x minus 8. Some of you might have said, well, we can just take half of this, and because both of those are even numbers, you can. I'm just going to do this just to show you for those people who need to see the entire thing. So first thing we do is we distribute. And then after we distribute, we're going to subtract 12x from both sides, leaving us with 2x. Add 30 to both sides, leaving us with 22. Divide both sides by x. No, divide both sides by 2, and x will equal 11. The question says, what is the measure of CI? So I'm going to plug that in. 7 times 11 minus 15 is equal to 62 degrees. To double check your work, if we plug an 11 into here, we'll get 12 times 11 minus 8, and hopefully that is double this, and it is. So we did things correctly. So the measure of arc CI is 62 degrees. Moving on to example 3. Example 3, I forgot to write what we're finding. In example 3, we are going to find the measure of arc VW. So we're going to find the measure of this entire arc. Well, looking at this, you might say, well, we're really not given much information. And we're not, but we are given enough. Before I go into this one thing on your homework will also be to find the length of this segment right here. If this is a right angle, this is also a right angle, giving us a right triangle. So we know we can use the Pythagorean theorem to figure out this missing leg. Now, we want this entire arc. Well, let's start by just figuring out this arc. This right here is a central angle. We know that the measure of a central angle is the same as the measure of its intercepted arc. So if we can determine this angle measure, we will have determined the measure of this arc. We have a right triangle. We know in a right triangle to find a missing angle, we can just use SOHCAHTOA. And so let me write that down so we know exactly which one we're going to use. We know that 13 is the hypotenuse. Therefore, we're going to either have to use sine or cosine. If I'm looking at this angle right here, 5 is adjacent to it. So therefore, I'm going to use the cosine of angle X, and that is equal to adjacent over hypotenuse. Remember, when we solve this, we're going to find the inverse cosine of both sides. And the way we write it would be this way. So those will cancel out, leaving us with just X is the inverse cosine. So we first always want to make sure you're in degree mode. And then inverse cosine, remember, is second cosine. That will give you the inverse. 5 divided by 13. And that will give you, the quiz is going to ask you to round to the nearest tenth. So that will give you 67 4/10. Now, if this radius is perpendicular to the chord, it bisects the chord and it bisects the intercepted arc. So if the measure of this is 67 4/10 and this bisects that arc, this is also 67 4/10. So to find the measure of arc VW, we just need to take this and multiply by 2, and we will get 134 8/10 degrees. But remember, you're not going to put a degrees in there. So there will be 2 questions on this where you're asked around to the nearest tenth, and they will be problems similar to example 3. I hope you understood all that. I will be at a Zoom meeting on Wednesday. For those of you who have any questions, I will talk to you later. Bye.